Hello, everybody, and thanks for joining us for the final match of the Brazil Open, Starkit against Hamburg Bitbots. Um, we have also a guest from Starkit,
Yeah, hi.
and I'm Florian, and I'm very excited for this game, and so let's step right in, I guess. So
Yeah, let's
here,
go.
here we are. I hope you're able to see it. Nice.
Yeah.
So, your robot is moving. That's a good sign for the start. Ours is not, so we were a bit spoiled by the ceremony, but normally it's like in the beginning a bit stressful, so that we hope no broken Docker was pushed or something like that.
Yeah.
Yeah. Especially as we keep quiet during the initial phase and only start in the ready. I have one question regarding your software stack. You have like a dual camera setup. Do you utilize both of them currently in the reward simulator, or is it some future-proof design?
Uh, can you repeat, please?
Do you use stereo vision currently with both cameras, or is it like a future-proof design that you intend to use it later on?
We are using stereoscopic cameras
Ah,
in real robot, in real game,
yeah,
if you're asking this.
yeah.
And this working on real robot, and it's about a year, I think, about
Oh,
half a year. We develop it, and for now we're developing like feature that
yeah.
we can extract from this because
Ah, okay.
we get like point cloud and,
Mm,
for example, enemy detection. For now, working from this from point
ah,
cloud. So today we submitted our champion team paper,
yeah.
and I think in days it will appear in archive.
Oh, cool.
So you can check our Docker, our model, so on. It will be in
Yeah.
paper.
I will definitely
Links
give it
will
a
be.
read. Um, yeah. What happened there? It was like a bit concerning. Your robot collapsed a bit. Let's say it's a hardware issue in the simulation. So this is the beginning. Now ready phase. I think you have kickoff. You have a pretty strong kick. We were a bit concerned about that. So we plan to go a bit further. Hopefully we reach this in time. But we're going way back. So yeah, it's working properly. We had
Yeah.
we
So we chose the same strategy
yeah,
again.
I saw that. Um, we had some issues during the Brazil Open with like um, when the enemy team wasn't connecting or had similar issues, the sim speed was pretty fast, and oh no, there we were a bit. Now okay, we're blocking it, but this is definitely not intentional. Hmm. Yeah, we had some problems with the sim speed. If it was dropping too low, no, if it was like going too high, our odometry couldn't keep up for some reason, and then we lost our localization. Therefore, we played like 1-0 against RoboFi or something like that, and some other teams that were nearly orientationless, but your robot model is complex enough that the sim isn't too fast. Oh, it's a bit rough.
It's a very
Okay.
quite strange rules about.
Yeah, the auto ref is sometimes a bit
Yeah.
special. Let's phrase it like that. We also had a thing where we definitely kicked Utra full on, and they got taken out. Yeah. This. Oh, are you able to score from that distance? Ah, nearly. Ah, that kick is damn impressive.
Yeah.
Oh, definitely an exciting match. So
Yeah.
it's definitely quite balanced. Now we can check our obstacle avoidance on both sides.
Yeah,
Looks
yeah.
like it.
We checked our obstacle avoidance against Robafay, I think the previous round. Oh,
Oh, it
uh,
works pretty good actually. Nice.
so the robot just goes through the field,
Yeah,
and after every hour goal, when we return into our side,
yeah.
we we like avoid the robot.
Mm,
This
yeah.
looks pretty cool.
We're doing it too, but not in a general way. Like we are explicitly using the robot detection and avoiding it, and we're also avoiding teammates via team com. But we have a
Yeah,
problem if they're too fast. Like if we're walking with full speed,
or
we're not able to do it in such a good way. And our sidekicks are definitely worth it. We aren't able to kick far, but we're able to kick 360 degrees. We also have videos where we kick backwards.
yeah,
It's not as useful, but
side kick
and
is quite good. Yeah,
yeah, if
def
it hits, we need like pretty accurate positioning to hit it, but it sometimes takes a bit. Yeah,
I saw that you're developing reinforcement learning, Volk.
yeah,
Uh,
yeah, definitely. Mark is working on it. It's his PhD thesis, and we're definitely doing some work on it, mainly in Pybullet, I think. But he was able to domain transfer it to Wibots and also to the real world. But it's like for the real world transfer and so on, it's like in the beginning state.
okay,
But
okay.
it looks promising. Until this walking is like it's like semi-closed loop. It has like a PID controller, but it's not the reinforcement learning walking we're currently using. This was mainly like an integration thing also. But we did some promising tests and rewards. Do you use any reinforcement learning in other components?
So for now, we like learning learning it and trying to implement something,
Yeah.
but we don't get any results.
Ah, okay. Yeah, it's. I think he just published a paper on it. I'm not really sure, or maybe it's going to be published. But yeah, he's doing some things with like demonstration with our current walking, and then using this to adapt it and stuff like that. I'm also currently doing my bachelor thesis, and I'm also doing reinforcement learning, but for the vision and the head behavior where you're looking, where you want to focus the attention on. Currently, it's like a very static pattern. Um, Yours
Yeah.
is a bit more sophisticated, I think. If I look at it, you're maybe doing some tracking, but also some scanning and stuff like that.
This is interesting. We use like static in forward way,
Yeah,
but we quite improve our head movement with wide angle lens, because for now we like
yeah.
see a lot of features at the same time.
Yeah,
For example,
you have a pretty wide angle lens. I labeled like a few hundred images for our new dataset paper that you sent us, and it was like nearly all things were visible in every image. It was a pain to annotate.
yeah,
Yeah.
yeah,
Do you hear me?
Hi?
yeah. Hi. Hi, this is Ilya.
I just wanted to ask if you're familiar with a paper of Juan Caseda and Svetlana Lajebnik. I've just seen a paper on reinforcement learning on active object localization, and you reminded me of the same topic. Is this the kind of hierarchical descent to a certain region of the field? That was a paper of 2015. I could share it probably.
Yeah. I'm happy to have related work. Thank you very much for that. I'm happy to get more related work. I'm using like PPO and the world model input to determine like the actions for the head directly in joint space. But I'm evaluating some models, and there has been some work in RoboCup 2 for it, like also working directly on the images. But I am not liking this approach very much because you're effectively training like a ball detector and for field marks using reinforcement learning, despite your normal detector, and this seems a bit inefficient to me. But I would be happy to see that paper.
Yeah, where could I send it?
And you can send it to via Discord, I think. You see my user in the channel. Oh.
Obstacle avoidance.
Yeah, I'm seeing it.
Oh, this is
We're
quite
also
interesting.
going for it, but we need a bit longer because we need to walk around the ball. But it's definitely an interesting game because both robots have like obstacle avoidance and some strategy and okay. And the halftime ended.
I've dropped the link to Off Topic.
Oh cool. Thank you very much. Why aren't we're penalized. I thought though no, maybe we're broken down, but it was just the referee.
Yeah.
Let me watch the chat real quick if we have gotten any chat messages. Oh. Hi. Nice.
Okay, this like.
Oh, what happened there?
This old bug, I think, with.
Did you get
kickoff?
Oh, the kickoff in the second time, the auto referee bug.
Yeah.
Yeah, we had that too. that's an old story where the game control and auto referee get out of sync regarding the kickoff. Yeah, it's a bit pain. We lost, I think, 1 or 2 matches in the World Cup due to that. Oh. Ah.
Oh no.
Oh no. And you got a free kick. Now let's have a look if we're able to handle it good enough. Oh no, the ball is placed like in our dead zone where we are not able to see it. I don't know if we're able to escape it or if we get taken out. Nah, we get taken out. So normally we handle all of these situations and place us in a defensive position and stuff like that, but there are some regions like behind the shoulders where we're not able to see it and need to turn, and the schedule is pretty tight when you need to leave the area around the ball at a free kick. And so in certain situations we are not able to get away. It was a bit brutal when we played against adult size. Did you see the video from the World Cup?
Yeah.
And the regions there are so large we are not able to leave them when we like walk very very fast directly because it's like I don't know 2 meters or something like that, and it's a few seconds, and no, it's not realistic for our small robots. Nice. Ah,
That kick works
yeah.
pretty good.
But you're definitely a bit faster sometimes regarding your pathing, path planning, and your decisions when to kick and stuff like that. Oh, and now we lost it. But I think you're doing obstacle avoidance, I guess.
I don't know.
Ah,
Oh no.
oh no. So, we're seeing the wall.
So we worked a lot to get like faster ball approach, faster decision making,
Yeah.
and I think the wide angle camera gives us a lot of a lot of improvement because we detect ball very quickly
Okay.
and can move to it.
Yeah. I
And
spent a lot of time fine tuning our ball approach and stuff like that. That we are not touching it in the wrong moments and are able to walk around it and stuff like that before the World Cup. But I'm not that happy of it either. It improved it a lot, but it's still kind of slow, I guess. Yeah. Oh,
oh,
obstacle avoidance.
so
Depends.
for now we don't use obstacle avoidance uh, near to the ball
Okay.
because
Because the ball. Because you don't want you want to be aggressive or like you don't want to go away if the enemy is at the ball or.
no, it's quite simpler. We're using Roban stack,
Yeah.
so they have like a placer that uses in long distances and
Ah.
use ball approach algorithm. So for now,
Okay.
we developed new ball approach algorithms based on tab approach from Ross,
Uh,
but we have some little bugs and
okay.
don't tune.
Yeah.
We developed it. It works on Railrobot quite good,
But not.
but we don't have time to tune it in VBot.
Okay.
So
Yeah. We're
we
using the same planner for the whole thing. It's actually quite a simple planner. It's like a follow the carrot planner. We used I think the DWA planner from Ross in the past, but weren't that happy with it and some parameters and stuff like that. So we wrote a simple one ourselves.
oh
Oh, the block.
classic.
Oh, and we fell down. We get up again. Oh, it's definitely an intense match, I guess. Oh, and we're going to the wrong. Oh no,
Yeah.
there we go. No own goal, please. Oh,
Oh.
oh, this was like tight. And we're publishing the ball as an obstacle so that we're not planning any routes through the ball
Yeah.
accidentally, but we need to deactivate it in the behavior in some good ways if we want to approach it, because otherwise the robot is too afraid of the ball and don't want to get near it. And yeah, that has some weird implications. I don't know why we turned there. But this was definitely a close call.
Speaking of the obstacle avoidance, don't you ever have such an effect that the robot could detect its own hands as another robot? Have you ever had that?
I don't know about the stereo approaches, but for our normal object detection, it's trained on such a data set that includes many of the robot's own limbs, and they're not labeled. and therefore the algorithm learns to distinguish them visually.
Okay, I see. When we were using monocular camera at the end of 2019, I guess, I have seen such a case just by myself when I was checking the the test data,
Yeah.
and the hand was randomly marked as Raban, and that was kind of fun because it literally means that it's self-aware, almost like like an elephant. He has seen only Rabans, another Rabans, and he detected himself as a Raban. That's impressive.
So do you classify different robot models really, or
No.
no?
We
Just
had we have collected a data set with only our robots in the lab. We were working on the
okay.
enhancing molecular vision-based
Yeah.
detection with the predicted field model, with the predicted depth channel, and we were collecting a data set for that and just
Did you
made
use
a markup.
molecular depth estimation?
Yeah, we did that.
Oh, cool! Because
in a paper.
we wanted to look into that and had some first promising results, but haven't investigated it. Oh, this is like ball avoidance. This is stretching it. Oh.
Our is dead.
Oh
no.
no.
But it should restart when referee
Yeah.
will pick up it. So we don't use like depth channel. We use like scale channel that we can obtain from like geometry information, because field is a plane and we know the position of the camera and so on. So we build like scale channel.
Okay.
And this improve map at high intersection over union, at 0.9 intersection over union threshold, about like, I don't remember, but it's like
25 or something percent. Yeah.
Yeah. Okay.
We have concatenated this channel to regular RGB channels, so the network was inferring kind of 1.33 times longer.
Yeah.
But with monocular camera. We had only monocular vision at that time, and we tried to investigate if we could outperform the regular vision by feeding to the YOLA, the tiny YOLA V3 another channel.
What kind of object detection algorithm do you use nowadays?
Still, what kind of what?
Do you still use YOLO with a depth map, but from stereo vision, or do you have another?
No, we detect the ball with like something in the bots. It's almost all in classical computer vision.
Okay.
This is OpenCV based approach, but in real life we use for now small classification neural networks that cast on the region of interest that extracted from some filters.
Okay. We use like a full-size YOLO, not tiny YOLO, in Rebots because we have the computation time for it and the resources.
And what version do you use?
It's a YOLO V4, and we use a V4 tiny on the real robot, and we've just publishing a paper regarding another architecture that Jan and I developed. And it's called Yo-Yo, and it's combining a YOLO detection head with a semantic segmentation detection head and a shared encoder backbone. So we are doing all of our vision things in a single neural network forward pass, like field detection, line detection, both pixel precise, but also like robot detection ball with some YOLO-like architecture. Yeah. Oh, the game is finished.
It's quite interesting. It's very interesting.
Yeah, the game just finished, and definitely good job from your side there. It was an impressive game, and it was another outcome than I expected. But yeah, I'm happy about it, and I'm glad you both joined us. It was pretty cool to have you here.
Yeah, thank you. Congratulations. It was a great match. Great game. Thank you.
Yeah, exactly. Bye bye.